Today we're going to be going over adding 3 or more vectors. So whenever we're adding the 3 or more vectors, the new strategy that becomes more useful is adding using components. Okay, and you can actually use this components method for solving just adding 2 of the vectors as well. But it's most useful whenever adding multiple vectors together. Okay, so in this method, each vector is broken down into its horizontal and component, vertical and horizontal component. Okay, so this requires the use of basic trigonometry ratios. So it's very similar to what we were doing whenever we have perpendicular, because it's creating this 90-degree angle. So we can use Pythagorean theorem, and then we can use these trig ratios, SOHCAHTOA. Okay, so each vector is like the hypotenuse of the right angle triangle, and it can be written as the sum of the horizontal vectors and the vertical vectors. So each vector is broken down into each of those, so the horizontal and the vertical component. Okay, so then what we do is we will later add those up, so we'll talk about that. So the important thing, though, is to make sure that you're naming the subscripts and keeping them separate. Okay, so here's some examples of subscripts that would break down the vectors or the displacement. Okay, so let's do some examples. It says find the horizontal and vertical components for each vector. So the first one is 75 meters per second north, 36 east. Okay, so let's go ahead and kind of get our angle. So here's our north. We're going to be going east 36 degrees. Okay, so this will be 36 degrees. And it's 75 meters per second. Okay. So we want to know this. Okay, so we'll say this is our vector y component. And then we have this part, and this is our vector x component, or the horizontal component. All right. So if we look at this, we can use our ratios. So let me first, we have a 90-degree angle here. Okay, and so from our angle, this is going to be the opposite side. This is the hypotenuse. And then this is the adjacent side. Okay, so first let's find the opposite side, which is our horizontal component. So we can do sine, because we do SOHCAHTOA. Okay, so we're doing opposite over hypotenuse because we have the hypotenuse, so we won't be using tangent for this. So sine of our angle, which is 36, equals our opposite, so Vx, over our hypotenuse, which is 75. Okay, so we'd multiply both sides by 75, find the sine of 36, and multiply. We should get that our horizontal vector, or vector of x, is equal to 44.08 meters, and if we look at the direction, it's going east. Okay, and then to find our vertical, okay, we can use adjacent over hypotenuse, so the cosine of our angle. So cosine of 36 equals our adjacent, which is Vy, over our hypotenuse, which is 75. Once again, multiply both sides by 75 and calculate it out, and we should get that our vertical is 60.67. Oops, and I forgot. This is meters per second, not just meters. Meters per second. And if we look at the direction, it is north. Okay, so we broke it down into its two separate parts. All right, for this next one, we have 4.3 kilometers south, 18 degrees west. Okay, so let me draw in my south. We're going to be drawing one that is southwest, 18 degrees. So this angle right here would be 18 degrees. Okay, so this would be our instead of velocity, this would be our delta D of y, and then we have delta D of x. Okay, because we know that this is direction, this one was velocity, so that's why we use v. And then our quantity was 4.3 kilometers for our hypotenuse. Okay, so here's our hypotenuse. For our angle, this would make this the opposite. This one is the adjacent. All right, so using the same trig ratios to find our delta D of y, it would be the cosine of our angle equals the adjacent, so delta D of y over our hypotenuse, which is 4.3, and we should get that our vertical is 4.09 kilometers, and it is south. Okay, and then for our horizontal, we're going to be using sine of our angle equals opposite over hypotenuse, and we should get that delta D of x is 1.33 kilometers, and then it's going in the western direction. Okay, so it's easy to add all the horizontal components together, then I'll add all the vertical components. So for example, if the vectors d1 and d2 and d3 are added together to find the total dt displacement, okay, it would look like this. So we would do the, we would separate out the horizontal, which would be the dx, and then the vertical. Okay, so this would be the vertical ones. Okay, so this provides the resulting vectors, horizontal and vertical components, and the resulting vector can be found using Pythagorean theorem. And the trig ratios. We're going to use the methods that we just discussed over adding multiple vectors in the component forms. Okay, so here in the example, a horse in a pasture travels 55 meters west, then 25 meters south, then 67 meters south, 17 degrees west, then 13 meters north, 33 degrees east, and then finally 24 meters north, 29 degrees west. Find the horse's total displacement using the component method. So first off, I'm just going to kind of label things out so that we kind of know what we're looking at. Okay. So first, let's just define what is positive and negative. Okay. So let's make north and east are positives and west and south are negatives. Okay. So we've been given a bunch of directions, okay, or displacements for our vectors. So let's go ahead and label them. So we have, and I'm going to use delta D. I'm going to name it I'm going to name it something else just to make this easier for us. So I'm going to name it N. Okay, so that we can, whenever we're putting it in, it's a little bit easier than writing out the delta D every time. Okay, so this is going to be N1, N2, N3, N4, and N5. Okay, so we have 5 different vectors that we're going to do. So we're going to break it up. Okay, so we're going to make this the horizontal part of it, and then this will be our vertical aspect of each of the ones that we're doing. Okay, so let's start out with N1. So N1 is 55 meters west. Okay, so if we break that up into our components, we should get that the horizontal is negative 55 meters. So if we were to draw the N1, it would be like this. So it's in the negative direction and it's 55 meters. Okay. And then the vertical aspect, there is no vertical aspect to this, so it's just 0 meters. Okay. For the next one, N2, we have 25 meters south. Okay, so if we were to draw this one, it would look like this. And so the horizontal aspect for this is 0 meters. And the vertical aspect is negative because it's going down 25 meters. Okay, so those ones were pretty simple because we're just going in a two-dimensional direction. All right, this next one we have N3 is 67 meters south, 17 degrees west. Okay, so we're going to have to break this up into its components. All right, so if we have our south and we're going west, 17 degrees there. And then we have our vertical and our horizontal aspects. Okay, so this is 67. So for N3, our horizontal x, that would be equal to 67 times sine of our angle, 17. So I just rearranged the sine ratio in order to get that. And so we should get that N3 of x is equal to 60, or sorry, it would be equal to 19.59 meters. Okay, and it is in the west direction. And then for N3 of y, we would get 67 times cosine of 17 degrees, and we'll get that N3 of y is 64.07 meters, and it is in the southern direction. Okay, so if we're going to break it up into our components, our horizontal one, which would be our N3 of x, is going to be negative, because it's in the west direction, negative 19.59 meters. And then for our vertical, our N3 of y is going to be negative, because it's in the southern direction, 64.07 meters. Okay. Our next portion for N4 is 13 meters north, 33 degrees east. Okay, so let's draw our little triangle. So we're going east, 33 degrees. Okay, so our vertical is here, and our horizontal is here. All right, so once again, we're going to set it up just like we did on the previous one. So N of 4x is going to be 13 times the sine of our angle. And we're going to get that it is 7.08 meters east. Okay, and then N4 of y is going to equal 13 times cosine of our angle, and we're going to get that it is 10.9 meters north. Okay, so when we break it into our different components, our horizontal is going to be a positive because it's in the eastern direction, 7.08. And then our vertical is going to be a positive because it's to the north, 10.9 meters. Okay, and then our last vector that we have is N5. And it is 24 meters north, 29 degrees west. Okay, so draw in our triangle. Scooch it over a little bit. So north, and we're going west. .9 degrees. So our vertical component is here, and then our horizontal. Okay, so we're going to have that our N of 5x is going to be 24 times the sine of our angle, which is 29, and we're going to get 11.64 meters north. west. And then for our vertical component, we're going to have 24 times cosine of our angle, and we'll get that it is 20.99 meters, and this one is going to be north. Okay, so breaking it up into its components, the horizontal one is going to be negative because it's west, 11.64 meters, and then a positive because it's to the north direction, 20.99 meters. Okay, so now what we can do is we can go through and basically add up the horizontal and the vertical sides. So for our horizontal, our in total of horizontal is going to be negative 79.15 meters. Okay, and just note that the negative means that it's in the western direction. Okay, and then our total for our vertical is going to be, so our total in the vertical direction is going to be negative 57.18 meters. Okay, and so since it's negative, we know it's in the southern direction. Okay, so now what we can do is we have the start of our triangle. Okay, so we have our horizontal is to the west, 79.15 meters. Let me zoom in a bit. Okay, and then we have our vertical component, which is to the south, 57.18 meters. Okay, so this creates the right angle. And so now we're just trying to find what the total displacement is along with what is the angle here for our problem. Okay, so those are the two things we're trying to find. So first we can find the delta D of t by using Pythagorean theorem. So delta D of t squared equals our a squared, which is 79.15, plus our b squared, which is 57.18. Okay, and we'll find that once we actually go through and do the math, that delta t is 97.64 meters. Okay, and so then what we need to do is we need to find the angle, and so we should use the two values that we've calculated earlier. So the opposite and adjacent. So here's the opposite and the adjacent sides, and then our theta, our unknown. So we're going to use tangent. So tangent of theta equals opposite, so 57.18 over our adjacent, which is 79.15. And so whenever we solve for theta, we should get that our angle is 35.8 degrees. Okay, so now we have to put together all of the answer to find the resulting displacement of adding the 5 different vectors. Okay, so we have that our final displacement is 97.64 meters, and we went west, right? Because if it's based off of this line here, we dropped down here, that's where theta is. So west, and then that angle was 36 degrees south.